So what I have here is really a question about limits, right? You notice the limit as x approaches 2, that's this value here, of 1 over x, which is our function, equals 1/2, and that's this value here. All right, so what we're doing here is if you think about the definition of a limit, right, the definition of a limit has the absolute value of f of x minus L is less than epsilon, and then on the other side is the absolute value of x minus a is less than delta. So what's going on here is we've been given this function, f of x equals 1 over x. We've been given the value we believe is its limit, and we've been given an epsilon value. But what we want to do is we want to find the value of delta that kind of goes along with it, right? We want to find a value of delta where if we pick any value of x within delta units of 2, the corresponding function value is within 0.1 units of 1/2. All right, so how do we do that? Well, I'm going to start with the thing we're given, right? We're given the absolute value of f of x, so that's 1 over x. So let's actually put the function in there. Minus 1/2 is less than 0.1. Well, the first step is to get rid of those absolute values. So this is the same as negative 0.1 is less than 1 over x minus 1/2 is less than 0.1. Now, we've got decimals out there on the outside. I'm not going to make those into 1/10. I'm going to make this 1/2 into 0.5. And now I'll add 0.5 to both sides. So the left side becomes 0.4. This is less than 1 over x is less than 0.6. Now, I need to get that x out of the denominator, and we can do that by flipping over all three parts of this. Right? So if I do that, this becomes 1 over 0.4, which is 2.5. Let's leave out the inequalities for just a minute here. Flip 1 over x over and you get x. Flip 0.6 over and you get 1.667. Now you notice when we do this flipping trick, we also have to flip the inequalities. You can kind of see why. 2.5 is bigger than 1.667. So we're going to have the inequalities going this way. Now that just looks really weird to me, right? So I'm going to flip this around so they're in the natural order. I'm going to put 1.667 first. That's less than x, less than 2.5. Okay, good so far. Now, I need to come up with a statement about x minus 2. Right, so I'm going to subtract 2 from both sides of this. Right, if I do that, this becomes negative 0.333 is less than x minus 2 is less than 0.5. And there's my interval. Right, there's my interval. If I pick an x value from this interval from negative 0.33 to 0.5, I can be absolutely certain that the functional value is going to be within 0.1 of 1/2. And that's good, right? We've got this interval. But we need a value of delta. And the thing about delta is it needs to be the same number on both sides of the inequality, right? So kind of what we've got going on here is this, right? We've got 2 here. And I have this interval from negative that's negative 0.33 to the left, 0.5 to the right. So it's going to be like this, right? This distance here is 0.333, and this distance here is 0.5. Well, I need them to be the same, right? I need this to be symmetric, right? So I can't make the left-hand side bigger. If I did, it would include some numbers over in here that may or may not give me a function value that matches my requirements. Right? So what I can do is I can make the left-hand side a little smaller. Right? So instead of being 0.5, I'm going to make this 0.333. And that interval also works. Right? It could have gone a little bigger, but not with the symmetry that I needed. So now I'm going to come over here, and I'm going to switch this. I'm going to make this negative 0.333 is less than x minus 2 is less than 0.333. It's positive this time. And this is the same as the inequality x minus 2 is less than 0.333. And that's what I needed to do, right? Jump back up here. This is the inequality I was aiming for, and this 0.333, that's going to be my delta.